All right, students, this is the video for practice set 5. And here we'll dive a little bit deeper into exactly what's happening, some of the intricacies of the equations or the concepts in a more hands-on approach, just so you have a better understanding of it. So let's start off with number 1. And in number 1, we just pretty much just jump right into it. Save this file. PB5, ABI 5 answers. All right, number 1. So there are two clusters. Cluster 1 has data points 4, 10. These data points are, think of an X and Y graph. So 4, 10 is one position, 1, 8 is the other position in cluster 1. And cluster 2 has 3 data points, 8, 5, 7, 4, and 9, 2. All right, calculate the error rate. Okay, so here we go. If you guys remember on slide 11 on your Lab 5 PowerPoint, I have the equation for the sum of squares for when we're calculating the error rate, right? I mean, I have the formula for the error rate, right? Which is basically the sum of squares of the center point of the clusters to the overall centroid data point, and over the sum of squares of every data point to the centroid of all the data points, okay? So let's first go to the PowerPoint so I can visually show you what's going on. Getting pretty good at this. So we have these 5 points, right? Hypothetically, we have these 5 points. I'm not going to put exactly where they belong. But let's say we have this point. We have this point, all right? And let's say these guys are cluster 1. All right? These guys are that first cluster 1, right? So these guys are cluster 1. All right, and there's another set of points, and that is cluster, that's, let's say, somewhere around here, hypothetically. Again, these aren't the actual numbers, just bear with me. And this is going to be cluster 2. All right, let me space this out just so it's like something like this. All right, so first off, for all the data points, we're going to have a main centroid point, right? The overall, we'll call it the overall centroid, or the centroid for all the data points. And this centroid is basically this center point. I'm going to color it something different. I'll make it, all right, I'll make it like green or something. All right. So this green point is the overall center point for all the data points. Okay. The denominator is basically going to be the sum of squares for every point, all 5 points, every data point, doesn't matter which cluster they are in, the sum of squares difference, right, from every point, that will be the summation of those sum of squares, basically the distance, right, without square rooting it, the distance without square rooting it, that summation of that will be the denominator, okay? So then what's the numerator? Well, within the clusters, within the clusters, each cluster has its own individual centroid, right, which I will make a different color. So when each cluster has its own center point, okay? And that I will make a different color just so you guys can see the difference. I'll make that red. I'll make that red. All right. Zoom in a little bit. All right. So each cluster has its own centroid point. Now, what's going to happen is the numerator will be the distance between the centroid, the cluster centroid, and the overall centroid. But you have to do it for the amount of points you have in the cluster. So it's literally going to be this distance plus this distance, right, because there's two, plus this distance plus this distance plus this distance, because there's 3 points. That will become the numerator. And then the numerator divided by the denominator will give you your error rate. So mathematically, let's jump on it, all right? So cluster, so first let's do the overall. Let me label them. Cluster X and Y, all right? And again, X and Y, think latitude, longitude, think our scaled versions of age and income, right? It's the dimensions we're doing the clustering on. And obviously, we can do clustering on more than just 2 dimensions, right? It's just 2, 3 dimensions are easier to visualize. All right, so data, so for cluster 1, we have a data point that is in the X4, Y10. We have another data point that is 1, 8. And now this cluster 2 has a data point that's 8 and 5, and 7 and 4. And the last one's going to be 9 and 2. All right? So the first things first, I need the centroid positioning for the overall data. How, pray tell, do I get that? This is algebra, people. You simply just take the mean. Oops, there is no mean in Excel. You inferior tool. Yeah, I said it. I said it, Bill Gates. All right. All right. All right, excellent. And it just works out that the centroid, all right, the centroid for our overall data is in the position 5.8, comma 5.8. Done. Done and done. Now what I need to do, so now I can go ahead and do my sum of squares for the denominator aspect, And remember, that's basically going to be applying the formula. It's going to be this minus that, square root, plus this minus that, square root. And we're just going to keep adding those points all up, all those sum of squares up for every data point. And that summation will be our denominator. So here, I will apply the formula. Equals. Actually, let me write the formula so you guys have it. So you guys see what's going on. And then we'll do the equals of it. So it'll be 4 minus 5.8 squared plus 10 minus 5.8 squared. And that's basically going to fall through for all these guys, right? It's going to be this guy, this guy, this guy, this guy. And obviously, the only thing changing is our x's and y's. So this is going to be 1. This is going to be 8. It's going to be 7. It's going to be 9. That's 10. It's going to be 8. This is going to be 5. This is going to be 4. and this is going to be 2. All right. So that's basically the math we're going to do. Here we can just apply the formula, and I will do literally this minus that. This minus that. And I get this value right here. Right, whatever that is. All right. C3, B3, excellent, excellent. All right, cool. And I just copy this down. I just copy that down. All right. B8, C8, excellent. B7, C7. All right, perfect. So this now, all these values, I will add up. And this value right here is the sum of all the sum of squares, and this will be my denominator. Done. This is my denominator. Now I need to do the numerator. I need to do the numerator. So how am I going to do the numerator? Well, I need to now do the same thing here. All right, I kind of ran out of space. So what I'm going to do is I'm going to just copy this all here. All right. And now I need to calculate the centroid for each particular cluster. The centroid for each particular cluster. So here now what I can do is I'm going to do a separate column. So let me delete this. Okay. And now I'm going to get here. This will be the cluster X, the cluster Y for each particular cluster. Okay. So this will be pretty, I mean, actually, I shouldn't even do this here. I'll just do it down here. So for cluster 1, all right, it's going to be basically the average of these two values. Right? All right, right there. So that's your centroid position for cluster 1, 2.5, 9. All right, for cluster 2, all right, I'm now going to do these 3 values right here. Perfect. All right, so this is the centroid, basically the red dots. These are the centroids for, this is a centroid for cluster 2, and this is a centroid for cluster 1. Now, I can go ahead and do my, basically do my calculation. But now what I'm going to do is I'm going to overwrite the values here by their respective centroid values. So this would become this. Right, this is kind of annoying. Oh yeah, that's the problem. All right, so let's do this. I'll just move it all here. This is why I originally did this. All right, so done, done. All right, so I copied over for each row, I copied over its centroid location. And now we're going to recreate, we're going to do the same calculation we did up here, but now, right, again, using the 5.8s, right here, using the 5.8s, but now instead of doing it to each individual data position, we're going to do it to the centroid position, all right, for each one. All right, so notice we repeat the calculation depending on how many points there are in each particular cluster. So this is going to be 2.5 minus all right, 9 minus boom. All right, do it for that, and I do it for that. Okay, now I do a different one for this one. Oops, no, I don't want to do that. I want to do this. 8 minus, again, 5.8. And there we go. B16. Can't see anything. B16. There we go. D13 minus B16. Excellent. E13 minus C16. Fantastic. All right. And that's what we want. And now we're just going to add this up as well. We get that over there, that number. And this already looks like it's going to be a bad error rate, but now the error rate is simply going to be, this is the numerator divided by that for a value of 35%. So that's bad. I mean, that has a bad error rate. We want it close to as 100% as possible. But nevertheless, that is the answer. That is the answer. For number one. And that's how you basically calculate the error rate. That's how the error rate is basically generated. All right, guys? That's the way it's pretty much generated. Okay, so here we go, 35%, and that's number one. Okay, number two now. I have to write code. All right, given the table food that has two columns, price and pounds, calculate the elbow graph from 2 clusters to 10 clusters. The units of prices are in dollars and the units of pounds are in hundreds. Look how, by the way, look how sneaky I am. I say I give you the units there, right? Why do I give the units there? Because if you're going to do this analysis, we got to scale that. We got to scale that, all right? We got to scale it. So for this, I'm going to, it's probably cleaner if I write the code in R script. So this I'll say, go to R code file, because I don't want to make a mistake if I type code in here. So here, let me open up a new. All right, and I'll call this PP5. I'll call it the same thing again, ABI PP5 barcode R answers. There we go. That's how we'll tell the difference. All right, so we're going to do number two. And then number two, again, this code won't work because you don't actually have a food table, right? But the code is basically saying we have a food table with two columns, price and pounds, all right? And we want to calculate the graph from 2 clusters to 10. Now, the first thing we need to do is we need to prepare our data, right? We need to prepare our data. So the first thing I would do is I would create a, let's say the 2 columns are price and pounds. Use the scale function. And the second one would be the pounds. Yep, pounds. All right, so now I'm going to do, and we talked about this before, we're going to calculate the elbow graph from 2 to 10. And we're going to calculate the elbow graph, and we're going to, I don't say it in the question, but we want to display it as well. All right, so to calculate it, I'll use the for loop method. This is, again, literally from our notes. The columns I want to cluster, price S, pounds S, and I want to do it in terms of I clusters. All right, and now I take this, I'm going to say I minus 1 equals MK dollar, and the actual one, I believe the name was, where are you? There you go. It's basically this code right here. Tot with an SS. exact thing. Boom, we run this, we're done. And now what I'm going to do is I'm going to create a plot table. Let's call it, whatever, we call it DT. And it's literally going to be the Ks from 2 to 10 and the WSS, right? And from here I have this table, and now I could just plot it. It will be literally the DT table. The aesthetics, I want the x-axis to have the K. I want the y-axis to obviously have the scores, WSS. And I want it to be a line. Yeah, done. That's it. That's pretty much how we do number 2. That's straight from the slides. Straight from the slides. Okay. Next question, number 3. Given the code below, and this is a code, looks like it's a code question 2. We are going to do, given the code below, change the graph from the first plot to the second one. See that? We have this plot right here. Change it from this one to the second one. Okay? And the cool thing is I actually give you the graph for it right here. And so how are we going to change it? Notice the name of the table is bike. Why are we having this? It is because when we color using this column right here, cluster 3 is a numerical column that is considered a numerical column in our bike table. This right here, when this one's colored, cluster 3 now in this case is considered a categorical column, So the code to fix this, right? I'll say again, go to the R code. All right, the code to fix this is basically going to be, was it bike and cluster 3? Boom, done. All right, that easy. All right, number 4, another code question. All right, that's number 3. Number 4. All right. Table DT has 5 columns, station K1, K2, K3, K4. Okay. The column station has the number of bike stations. Okay, station. The column station basically has the number of bike stations. Okay, stations. So bike station 1, 2, 3, 4, 5, 6, whatever the amount of bike stations there are. K1 has the distance from each bike station to that kiosk. K2 has a distance from each bike station to that kiosk, etc., etc., etc. K3 and K4, etc., etc. It's basically the distances from each of those bike stations to each one of those 4 kiosks. Calculate the average distance between each bike station and the third closest kiosk. So I want to calculate the average distance between each bike station and the third closest kiosk. Okay, the third closest kiosk is the same thing as so the third closest kiosk is basically going to be the same thing as the second furthest kiosk. So we understand that, right? The third closest kiosk is the same thing as the second furthest kiosk. And this should not be a problem. So I have this table DT. Number 4, first of all, let me just say, again, go to R code. All right. And number 4, table is DT. And remember, we have station, K1, K2, K3, K4. Okay, so basically, I want to create a new column that's going to be the second furthest, right? This is going to be the second furthest. To do that, I need to be able to, I need to first get the maximum distance, So let me create, I need to get the maximum distance because I need to ignore the maximum distance and then take the max of the remaining columns. So bear with me. So here basically we're going to do is I'm going to first get a column that says maximum k. So I'll call this maximum distance, or MD for maximum distance. All right. And this is going to be easy. This is going to be basically all the 4 columns, right? And actually we have a function for this. If you guys remember from the notes I gave you, we have a pmin function. We also have a pmax function. All right, and let's confirm right here. Show you guys, show right here. I have the code right here. Actually, it's perfect. Right there, pmin. So along with the pmin, we have a pmax function. All right, so I'm going to use the pmax one, and I'm going to put the columns that I want to take. Get the largest value for all of them, basically. All right, done. So MD will now be a column that's basically going to give me, it's going to give me whatever out of these 4 columns has the largest value. It's going to be an MD. Done. Now, from here, I'm going to go get another column called the second max distance. All right, and I'll call it SMD for second max distance. Right, and again, the second max distance is always the same thing as third closest. And now this is going to get tricky because now what's going to happen here is I need to do the Pmax, but I can only do it on the columns that are not the maximum, not the furthest away. How am I going to know that? I'm not, unless I use the MD column. So if I say, for example, K1, where K1 equals MD, K1 is going to be for all the rows. This is going to select for all the rows where K1, the kiosk 1, is the furthest away, because the MD value and the K1 are the same. So therefore, I know that I now want to do a Pmax with all the values that aren't K1, K2, K3, K4. And now this is going to give me, SMD will now become the maximum out of these 3, which are not the furthest away. That would be K1. That would be K1. And so the max out of these 3 would be basically the kiosk, the distance of the kiosk, that is the second furthest away, right? So that's the logic behind that. So I'll do the same thing with K2, where K2 is the max. Get rid of that, put that 1 there. Same thing with K3. Get that sucker out there, K1 for that. And of course, K4. K1 there, done. All right, you run all these. I now have an SMD column, which is the second furthest. And in the question, I said, calculate the average distance between each bike station and the third closest. Again, the second furthest. And so now the average distance is, I'm simply just going to do DT, all the rows. For all the rows now, just take the mean of SMD. Done. So easy, just like that. All right, number 5. Given the data points 410, 18, 85, 74, 92, 5 data points. I only have, oh, perfect. 4, yeah, okay, I can't read. Given these 5 data points, guys, calculate the 5 levels of clusters of 5 to 1. Okay, of 5 to 1. So we're going to do a hierarchical clustering over here. Using the single linkage method, complete linkage method. Remember, single linkage method? Minimum. What is complete linkage method? Maximum. What is the average method? Average. And what is the centroid method? The centroid method is basically the middle of each cluster, respective cluster. All right? calculate the, given the 5 data points, we want to calculate the 5 levels of cluster. So basically, we want to calculate how the hierarchical cluster, basically, theoretically, would go from these 5 clusters. Each data point starts off being its own cluster, and slowly go up to one cluster. All right, and we're going to do it for each one of these scenarios. So this could take a little time, but all right, for number 5, we'll start off with for single linkage, which is again the minimum, guys. So we give the, we have all the points, so let's name these points. It's a little bit easier. Point x, y. So we'll call this point 1, 2, 3, 4, 5. Okay. Because it's going to be, we need to name the, it's easier to name the points when we create the little matrix thingy. The distance matrix, basically, guys. All right. So point 1 is 4, 10. It's basically the same as before. 1 and 8. 8 and 5. 7 and 4. And 9 and 2. All right. So those are our points. Now, what do we need to start off with? And no matter what methodology we're doing, we need to start off with the basically, get rid of that row. We need to start off with what would I call the distance matrix. We need to know the distance from each point to each point. Now, what's the distance from each point to each point? That's the Euclidean. That's the Euclidean distance, like in a 2-dimensional space, even a 3-dimensional space. The Euclidean distance formula tells you the distance from one point to another. You guys, that's geometry. You guys remember what that was, right? It's very similar to our sum of squares formula, except now we take the square root, right? It's very similar to our sum of squares formula, but now we take the square root. That's basically it, right? And again, I have the formula on my notes if you guys want to take a look at it, right? I think it's slide 45 if you want to take a look at it, slide 45. I give you that example, right? Because remember, the high cluster, the H cluster function requires a distance matrix, and the dist function does that for us. But again, it's the same formula pretty much as a number 1, except now we just square root it, all right? So here we go, all right? So I'm going to create, let's close this off a little. So I have 5 points, so I'll try to do it just like they do it in R. They do from like point 1 to point 2, point 2, 3, 3 to 4, and 4 to 5, right? And we'll just fill in the ones going down here, all right? So let's start off with, and again, this is the way R does it, right? R doesn't bother calculating 1 to 1 because, you know, we know 1 to 1 is going to be 0, the distance. So anyway, we start off with 1 to 2. All right, what's 1 to 2 going to be? 1 to 2, right? I'm going to put the formula directly in here. You guys can go check it out, but it's basically the application, the same distance, like the same equation if you want to think about it. It's going to be, for example, I'll put that up here. 1 to 2 distance example. Right, so it's basically going to be the square root. I can't put the square root. So square root, first let me do this part. It's going to be 4 minus 1. Right, it doesn't really matter which one you put first, just be consistent about it with the x and y. Square plus 10 minus 8. And this is like our sum of squares from number 1. But the only difference is now we apply square root to the whole thing. Oh, forgot the 2 there. There you go. Oh, I got rid of that. All right, cool. So that's basically the formula we're going to apply for the distance between 1 and 2, and we're going to do it for all these guys, right? So 1 and 2 is going to be basically this. Let me copy that. Done. All right, now, ooh, 2 to 1. Oh, I'm sorry. Usually the way they do it is, I think they do 2 to 1, 3 to 4, 45. So let's change this to this. 3, 4, 5, 1. It's just easier to read it this way. All right, yeah, there we go. All right, so 2 to 1 or 1 to 2, whatever. That's going to be the answer. All right, 3 to 1 is going to be, I'm going to copy this and change the formula up a little bit. All right, instead of, guys, 4, so from 3 to 1, it's going to be, instead of 4 minus, I have it all backwards now, but let's change it. So now it's going to be 8 minus 4. And 5 minus 10. Bam, and that's the distance between 0.3 and 0.1. And now let's do it between 0.4 and 1. 0.4 and 1, and yes, we have to go through calculating all these points, right? So 4 and 1 is going to be 7 minus 4, and 4 minus 10. Right, a little bit faster as we. And 0.5 and 0.1 will be 9 minus 4 and 2 minus 10. Done. All right. Okay. So that's for all the points from 2, 3, 4 to 1. And now we go down, right? I don't have to obviously from do 2 to 2. I just now have to do from 3 to 2, 4 to 2, and 5 to 2 because I already did 2 to 1. And that's why slowly it gets less and less calculations. All right, so now we're going to knock out these guys right here. Copy this. So from 0.3 to 2 is 8 minus 1. And 5 minus 8. Four to 2 is going to be 7 minus 1. And 4 minus 8. And 5 to 2 is going to be 9 minus 1. And 2 minus 8. All right, excellent. Now I don't need 3 by 3. I need 4 by 3. 4 by 3 will be 7 minus 8. And 4 minus 5. And 5 to 3. 5 to 3 will be 9 minus 8. And 2 minus 5. All right. And finally, now we're doing 5 to 4. And 5 to 4 is going to be 9 minus 7. And 2 minus 4. All right, so not that painful. So we have our distance matrix, and we're going to keep using this distance matrix we'll use over and over again for all our other strategies. All right, so here we have the distance matrices, and now I can begin my clusters, right? So we start off at level 1, or 1, we could say 1. At 1, the clusters are going to be 1, 2, 3, 4, 5. Done. The 5 clusters. Easy. Okay? Now at point 2, what are we going to do? We're now going to combine our first two clusters. Right? Again, this is going to be easy. We simply take the smallest distance. Which one has the smallest distance, guys? Here, I'm looking. All right, this is the smallest distance, 2 to 1. 2 to 1. Ah, this is smaller, 4 and 3. And that's it. It looks like the clusters 4 to 3 have the closest position. So guess what becomes our first joint cluster? 3 and 4. So at stage 2 now, we're going to have the 1 cluster, the 2 cluster, the 5 cluster, right? And I'll put and cluster number 1, which is going to be 3 and 4. You see that? Now that's how we went from 5 to 4 clusters. 1, 2, and 5 are still their individual clusters. But cluster 1, the first official cluster, more than 1 point, is going to be 3 and 4 combined. Now from here is when our algorithms kick in. On the next stage over here, right? Well, what's going to be the we need to now calculate what's the next shortest distance from 1 to 2, 1 to 5, 2 to 5, and all these points to cluster 1. So the question is, what's the difference from these points and cluster 1? And that's what our algorithm tells us. That's what our algorithm tells us. That's the different mathematical techniques to do this, to figure that out. We are working obviously still on the single linkage methodology, which is the minimum, all right? So if I had to redo this, if I had to rejigger this, I'm going to do paste as values. So, okay. And now what I'm going to do is I have 1, 2, and 5. So here, 3 and 4, they're gone. All right. So I have 2 to 1 is that, 5 to 1 is that, 5 to 2 is good, and so that's 1, 2, and 5. Excellent. 3 and 4, we'll delete this. All right. But now we're going to place 3 and 4 with cluster 1. Okay. Cluster 1. Over here, and or should we actually, let's not do that here, put it here. Cluster 1. All right, so now we have cluster 1 here. And now what I need to do is I need to calculate the distance between cluster 1 and 1, cluster 2 and 2, I'll throw 5 up here, and cluster 1 and 5. All right? So what's the difference between cluster 1 and 1? Well, what's the points in cluster 1? It's 3 and 4. Which one is the smaller distance? It's 3. This is, again, single linkage. So that's the distance between cluster 1 and point 1 now. What's the difference between distance between cluster 1 and 2? All right, so that's, again, these 2 points here, 3 and 4. What's the smaller one? It's 4. Take this guy, stick there. All right, and now what's the smallest distance between cluster 1 and point 5? Cluster 1 and point 5, so that's 5 here. 5 is here, and 5 to 3 and 4 are these two values. Right, so out of these two values, which one's the smaller one? That one. Bam. That's how the new distance matrix is created now, using the minimum value. Using the minimum value, you see the minimum value. Now we can look at this, all right? And technically, we probably should have recreated this distance matrix first. So let me do this. Let me move this down here and scroll this bad boy up. All right, there. So now we can answer our question, guys. What should be the next level? the next level. Well, what's the smallest distance up here, guys? 3, 6, 9, 10, 2. Okay, it's this right here. This point right here, which is between cluster 1 and 5. So guess what? Now we're going to have the 1 cluster, the 2 cluster, and cluster 1, which now is going to be 3, 4, and 5. You see that? Okay, it's going to be now 3, 4, and 5. Now to get to my next stage, all right, we're going to keep going until we have like 2 clusters, or obviously 2 clusters, because the next stage it just becomes 1 cluster. They all just go into one big cluster. Let me move this over, right? And now I'm going to recreate the distance matrix. I'm going to recreate the distance matrix, but now just for 1, 2, and cluster 1, which is now 3, 4, and 5. So here we go. 2 and 1, I need that. 5, you're gone. You're gone. You don't exist anymore. 5, you're in cluster 1. You are gone. Gone. All right. So 2 to 1 is still the same. Cluster 1 to 1 is now what? So I go back up here, right? I go back up here to my main one. Cluster 1 to 1, again, is 3, 4, and 5. It is still, 3 is still the smallest one. I leave that there. Cluster 1 to 2, again, 3, 4, 5 right here. The smallest one is still this value right here. I'll leave it right there. And I'm done. I'm done. Because now I have the distance between 1 and 2, and cluster 1 and 1, and cluster 1 and 2. So we're good. I have all my distances here. And so the next stage right here, guys, is what? It's going to be, what's the smallest distance here? The smallest distance, guys, is now here, between 1 and 2. So now what happens? Now I have cluster 1, and now I have cluster 2. That is the point 1 and 2. Do you see how these clusters are made hierarchically, from a hierarchical point of view, depending on the algorithm you use? And now my answer is very simple. I'm done, because the next stage is going to be just one giant cluster with 3, 4, 5, 1, 2, right? So I'm pretty much done at this point. This is how the different stages happen, and we create the different clusters, okay? So this was for single, and now we're going to run this back. We're going to run this back. I'm going to copy this again, right? And this time it'll be faster, because we already did the hard work. And now I'm going to do, let me do it as values again, just so I just need the values, the cute little values. And now I'm going to do for, where are we? Complete linkage, single linkage, and complete linkage. Now I'm going to do it from complete linkage. All right, complete linkage. And now what's complete linkage? What's the difference? The difference is that before, for the cluster, it was going to be stage 2. We were going to basically say, look, what's the minimum value? And the minimum value is still going to be the same here, guys. Again, we say that stage 2 is going to be the same as well. I'm going to copy this, because even though it's complete, because when you have the individual points, you're still finding the smallest distance. And the smallest distance here, guys, is here. No. Here, sorry. 3 and 4. So this part will be the same again. At level 2, again, it'll be the same again. Right? You're going to have 1, 2, and 5, and 3 and 4. At the next stage now, things change. All right, the next stage now, things change. Let me slide this down. Because what happens here is, once you're presented with that cluster again, all right, so here, all right, so at this point, guys, what I'm going to do is I'm going to say 1 to 2, it's fine. 3 and 4, these guys are gone, like last time, because 3 and 4 is now cluster 1. Shift it up. All right. Oops. Right there, but these guys are gone as well. And now, let me move this down right here. Sorry for all the moving around. I'm just trying to keep things organized for you guys. So I'll put cluster 1 back up here, all right? All right. Cluster 1 again is 0.3 and 4. Okay, now, what's the distance between cluster 1 and 0.1 now? Here I look at this again. Single linkage was the minimum. Complete linkage is the maximum. Now it's going to be this value right here. Cluster 1 to 0.2 is now this value, the maximum distance. All right. That is basically 2 to 1, 5 to 2. Yeah, and sorry, we have to add another one. We have to add to 5 as well. I knew I was missing something. And from cluster 1 to 0.5, 5 here, these guys right here. So which one's a larger one? It's going to be this one. Put that there. All right. Okay. I have this distance matrix, and it just so happens that the next level is going to be the same thing again. The smallest distance here, again, even though we're using complete linkage, is going to be cluster 1 and 5, right? So copy that. Right? And this is the scenario ends up the same, although we're getting it there a different way. All right. Now we have to recreate our distance matrix. Let me slide this down again. All right. Copy this. All right. 5 is gone now. Five is gone. All right. So now it's just going to be 1 and 2. That's fine. Now cluster 1 and 1 is now we're looking at 3, 4, and 5. What's the largest value here? Oh, okay. This is now. That changes. All right. Cluster 1 to 2. 1 to 2 is going to be, again, 3, 4, and 5. Oh, that changes. All right. And now we see what the smallest position is. There's no surprise. It's this again. And again, we end up with the same kind of clusters again. We're going to end up with this right here. We got the same answer. We just got there differently. All right. And our distance matrices are different. So that's basically how the scenario would play out for complete linkage. Now from here, I said, what is the average method? Average will be relatively easy. We just have to do a little extra math. All right, so I'm going to copy this again. All right, average. And now we start off again. Our first 2 will be the same again, right? Because at stage 1, everything's 1, 2, 3, everything's individual. At the next stage, the smallest one is going to be 3 and 4, right? And now we start off at 0.3. Right, at 0.3 now, we're going to have to create the clusters. And again, at this point, I can actually steal this as well. I should have been stealing this from the beginning. Right, at least this right here. Let me move this over. All right, so here, put this down. All right, so here, obviously, let me blow this away. This is from the maximum ones, right? These are obviously going to be the same again. All right, so from cluster 1, using the average method, 2.1 is going to be, again, 3 and 4, but this time it's neither going to be the minimum, nor is it going to be the maximum. Now it's going to be the average. Now down here, when I highlight this, I can see in my Excel what the average is 6.555. So I'll write down 6.55. Done. That's the average. All right. I'm sorry, what am I wrote the wrong place. Here, 6.55. All right. Now from cluster 1 to point 2, cluster 1 to point 2, what's the average? 7.413. And from cluster 1, which is these two, to point 5, the average will be 2.995. Done. All right. And again, when I see what my minimum value is, again, I'm going to get the same answer, because here, this is the smallest distance. So again, I'll just copy this line right here. Not very exciting. I apologize for the numbers I chose. But here, at stage 2, again, we're going to have 1, 2, and 3, and 4, and 5. So I'll take now this one, since this worked out the same as well. Put that there. Slide this down here. All right, delete this. And now, from cluster 1 to point 1, it's going to be all these guys, the average of these guys, which is 7.515. All right. From cluster 1 to point 2, it's going to be 8.275, or 8.276 to round it. All right.